In this review video, we're going to talk about imaginary numbers. We're also going to talk about operations with imaginary numbers and with negative radicals. But first, we're going to start off talking about what imaginary numbers are. An imaginary unit I is defined as I equals to the square root of -1 or I square equals to -1. Those are two critical components of imaginary numbers. Those are the two key elements dealing with imaginary units. Now, the pure imaginary number is written in the form of bi. Now, notice that is bi. It is not bi square or bi to the third or bi to the fourth. It has to be bi to the first power, where b is the real number and I is the imaginary part. That is why it is critical to know that I square is always equal to a -1. Because if you have anything bigger than an I, you have got to break it down into all of its I square parts, which I will show you in a little while, and deal with that. All right. So the first example, number 1, it says write each radical as a complex number. Well, you've been told for a long time you can't take the square root of a negative number. So what we're going to do is we're going to make this a positive radical by separating out the square root of -1 from the 144. Now we know from the rules of multiplying radicals, if we multiplied that back together, we would get -144. So I can take the square root of 144, and the square root of -1 is I. There is my complex number bi. Notice it's not bi square or anything like that. It's just 12i. Same thing for number 2. I'm first going to take out the square root of -1 and then make the 80 positive. I took out the imaginary unit square root of -1. Now I have to break down the square root of 80, and that would be perfect square 16 and non-perfect square 5. So I can take the square root of 16, I can bring out my imaginary unit and leave my square root of 5 alone. Now, it applies to square roots of negative fractions as well. So I'm going to break this down into the square root of -1 times the square root of 36 over 121. I can take the square root of 36 and 121. That becomes 6 over 11 with an I behind it. So my final answer would be the complex number 6 over 11i. Now, in the next little chunk of this particular section, we are going to talk about what happens when you have something bigger than an I. So in the first example, I to the first power is the same thing as -1, so it stays I. Well, I square, I have an I square, and we already talked about the fact that that is going to be a -1. Every time you have an I square, it is a -1. The reason being is every I equals to the square root of -1, and then when you square it, the square and the root cancel, leaving you with -1. Now, in the next example, I need to break this up. Now that I know I square is equal to -1, I can split up that I to the third into I square times I. That gives me -1 times I, because every I square becomes a -1. So I end up with -I. In the next example, I to the fourth, I have I square twice, which means I have -1 twice, which gives me a 1. Now notice that there is a pattern. With the odd powers, 1 and 3, my answers are I's or -I, and with the 2 and the 4, I get either a 1 or a -1. Now watch how this pattern emerges on the right-hand side with I to the 5th all the way through I to the 8th. Now keep in mind, anything that has an odd power, like I to the 5th and I to the 7th, they will have I in their answer, but you have to determine whether the I should be positive or negative. So in example I to the fifth, we have I to the fourth times I. We just said that I to the fourth is 1, so that would be 1 times I, and I get I. I to the sixth would be I to the fourth times I squared. That would be 1 times -1, which is -1. If I come back over to my left-hand column, that's where I'm getting these numbers from. In example I to the seventh, I have I to the fourth, which I know is a 1, times I to the third, which I know is a -I. So I get I times -I, which is -I. And then I have I to the fourth squared, which is 1 squared, which is 1. Notice the pattern. For every odd power of I, you end up with either I or -I, and it's an alternating pattern. And if you notice, the even powers of I are alternating ones and negative ones. So keep that in mind. All right. The last set of problems that we're going to do for this particular video is we're going to evaluate powers of I. So in the first one, I have I to the 11th power. So I'm going to break that down. Now you can do it several ways. The first thing I'm going to do is I'm going to break it down to I to the fourth, because I know that I to the fourth is a 1. I am also going to break down another I to the fourth, and then an I to the third. So I'm going to break it down as small as I can. Well, I know that I to the fourth is a 1. I know that I to the fourth is a 1, and I know that I to the third is -I. So my final answer is just -I. Now, when it comes to the number 5, -3 stays out in front, and then I have to break down that I to the 21st power. So I'm going to do this one just a little bit different because that exponent is so large. Now, out of this, I can break this down to I to the 20th times I to the first. That is still I to the 21st power. Now, I know that there are 5 4s in I to the 20th power. So what I'm going to do, move this down just a little bit so we don't run into that one. So my -3 stays there. I'm going to write this as I to the fourth to the 20 or to the 5th power using my exponent rules backwards. I to the fourth to the 5th power times I. Now, I to the fourth is equivalent to 1, and 1 to the 5th power stays 1, so I get -3 times 1 times I, so I get -3I. Notice that I no longer have an exponent bigger than I to the first power on my imaginary unit. In number 6, I need to multiply these terms together first, so that gives me 108 I to the 16th power. Now, once I get to that part, I need to break down my I to the 16th. Well, I know that I to the 16th has 4 I to the 4th powers in it by using my power property backwards. So that would be 108 times 1 to the 4th power, which would just simply be 108. When I go to do number 17, I have to raise 2I to the 9th to the 5th power. So 2 to the 5th is 32. I to the 9th raised to the 5th is I to the 45th power. Now, I need to break down that 45. Well, 45 is not evenly divisible by 4, but I can split that up. So my 32 stays. And then I need to break down I to the 45th into I to the 44th, which is divisible by 4. times I to the first. That is the breakdown of an odd power. Now, I told you every odd power of I is either going to have an I or a negative I outcome. So what I need to do is I need to figure out this part. I need to figure out my I to the 44th power. So 32, if I do the reverse order of my power property, that would be I to the 4th raised to the 11th power times I. Now, that gives me 32 times 1 to the 11th power, because I to the 4th is always a 1, times I. So I get 32I as my final answer. In number 8, you've got a combination of things going. You have to use your power property of exponents and then your product property, and then we're going to turn around and kind of undo all of that. So in the first part, negative I squared to the 5th power stays negative I to the 10th power, and we're going to multiply that by negative 3I to the 10th raised to the 3rd power, which gives me negative 27 I to the 30th power. Now, that was the power property of exponents. I'm going to apply the product property, which means I'm going to add up those exponents. So negative I to the 10th times negative 27I to the 30th becomes positive, because a negative times a negative is a positive, I to the 40th power. Now, since 40 is an even exponent on my I, I'm either going to have an outcome of 1 or negative 1. I just have to figure out which one that's going to be. So 27 I to the 4th raised to the 10th power, use that power property backwards. That would be the same as 27 times 1 to the 10th, which just gives me 27 total. Final example for this particular section is that we're going to use the product property, or the power property, and then the product property again. So the square root of negative 9 raised to the 3rd power, I'm going to break down the square root of negative 9. Square root of negative 9 breaks down to square root of negative 1 times the square root of 9, which is 3I. So I get 3I to the 3rd power, which is 27I to the 3rd. I'm going to multiply, or I'm going to simplify the 2I to the 6th, which gives me 64. 2 to the 6th is 64, I to the 6th power. Now, I'm going to multiply all that together, and that gives me 1,728 I to the 9th power. Now, since my power of I is odd, I know I'm either going to have I to the 1st or negative I to the 1st power. So I need to break that up. So when I break up I to the 9th power, that would be I to the 8th times I. That gives me I to the 4th squared times I. And I to the 4th is 1, and 1 squared is 1. So my final answer, sorry, I'm running down into the next little section, is 1,728I. I hope this kind of helps with your review of imaginary units. The next lesson will be talking about complex numbers and the operations that deal with complex numbers and imaginary units.